Thank you very much for letting me present on a local project with some more recent data, which I think you guys might find very interesting. I'm also looking forward to hearing the results of the other projects in the Burdekin, because I know there's been some really big projects, pesticide and, P2R type stuff. So I'm really looking forward to hearing that. Hopefully I can do some justice to this project. Put a lot of time and effort into it. There's a lot of people in this room who put a lot of time and effort into it. And we think we're getting some pretty good results. Growers have been on board and being really proactive in appreciating the fact that we've been able to present some of this data based on some of their properties. So the aim of the project was to guide growers to wider adoption technologies and approaches that will deliver water quality improvement through smarter irrigation practices. There's a whole heap of objectives, but these are the two that I really focused on as a sort of a leader of the project. Transitioning growers to proven world-class, sustainable, technologically advanced practices in irrigation management that are scalable, and maximise industry profitability through smarter irrigation practices. Really, really important. No point we go ahead and make all these magnificent changes and then impact our productivity, profitability for our growers. So what has Burdekin Irrigation Project been able to do? So, big one, evaluate the system, measure and monitor. From that is measurements and monitoring. We've been able to make some really, really good decisions. Those decisions have been based off all those dot points that you see down the left-hand side and more. Ground truthing, soakage, one big question that constantly gets asked, and basically collecting that information initially, finding out what's actually going on, finding the constraints that are happening on farm, and then making some decisions about how we can help the farmer, how we can improve the productivity and profitability of this farmer. The expressions of interest were put out and we had very, very good returns on those expressions of interest. So once growers were selected, or not even selected, once they applied, they actually then got an opportunity to work with the delivery team, which is a consortium of service providers that went out and collected baseline assessments. So that was going out with the growers and looking at irrigation cases. Usually they were some of the harder cases, not all the time. Looking at particular blocks and collecting this information with them and then finding out the constraints. Is there a pump that's not working the way it should be? Is there a valve or a cylinder that isn't in the right spot? Or the lay of the land is incorrect, or soil types differ throughout the system. Collecting all the information on energy and then actually coming up with what we're actually currently doing and then coming up with a desired outcome. From that desired outcome, we'd also look at the economic impact on changing. The smart irrigation tools were developed within the project, so every grower had an opportunity to take advantage of these smart irrigation tools. You can see from the left-hand side, we've got potentiometers or if you want to call it capacitance, or single point, moisture probes. That's what they are. Anything from single moisture probes to pump timers, manual pump timers, automatic pump timers, and of course full automation. All of these things were selected. There's VFDs, there's lots of other stuff on the left-hand side there. But farmers wanted automation. And it makes sense. Irrigation is one of the hardest jobs, not the hardest, but the most, it's one of those jobs where you just got to be there all the time. You can't take a holiday when you're irrigating crops. You need to be around all the time. So automation was obviously high on the agenda for a lot of the growers. As a matter of fact, over 95% of the growers wrote on their expression of interest that they would like automation. So that's overwhelming. Overwhelming from a project's perspective as well, because it wasn't set out or planned to run like that. It was set out to have some of these tools that only cost $400 to put in. So there's some challenges along the way. I'm not going to lie about this. So the automation, linking technology autonomously. I don't like to call it just automation because it's a multiple of different types of equipment, smart technology that link together. So you've got control, pump control. It can automatically turn a pump on and off and open an actuator valve on and off. You can be anywhere in the world to do this. This is what's important. But you've also got sensors through the paddock, moisture probe sensors, potentiometers, end-of-row sensors, advanced sensors, recycle pit sensors. You've got to remember, a farm is very complex. It's not just start the water at the start of the row and then, forget about it, and then turn around and come back another day and have a look at it or whatever. It's very complex. Recycle pits make that extremely complex. You've got sensors in recycle pits that tell you it's low or high. We wanted to create farms that were autonomous in irrigation. That was the role of us. Uplinking the data to Irrigation and autonomous record keeping was high on the agenda for the farmers. I don't want to record keep this, and I don't blame them. I used to do it. Go out every 6 hours or 8 hours or 10 hours or whatever it is and write down, oh, this is the pump time, this is the valve shut. It takes a long time, and most times you forget some. Demonstration sites were probably the most difficult things to set up during this project. It is very hard to do replicated strip trials with irrigation. It is very rare to find a square block with the exact amount of valves and the exact amount of rows, and all the ducts have to align to do this. But as well as that, we want to be able to do it in different soil types and different regions within the Burdekin. So we have a Briar farm, we have a Delta farm, we have one, you could more or less say it's half Briar, half Delta. And that's how we started. So we had to first get growers to actually turn around and say, I want to be a part of this, explaining to them this will be difficult. Then we had to say, is your infrastructure going to work? And you can see here, so you've got the grey section, which is what we call the control. So that's from the baseline assessment, going out with the grower, capturing how he irrigates that particular farm. And then these darker blue or purple, whatever you want to call it, is what we call the BIP irrigation, the desired outcome that we were trying to achieve. We also always had a spare set just to experiment with. And the farmers were really, really appreciative of that because they could see everything that happens. We did that on all the sites. All 3 sites had the same scenarios. Again, not easy to set up. Takes a lot of work to make all this happen. There are sensors. You can see down the row, they're called advanced sensors. So we'd be able to capture water when it hits 150 metres, 300 metres, 450 metres, 600 metres. That's really important when you've got a soil type that runs across through the middle of the paddock that changes the way the inflow rates work. We modified the inflow rates on our BIP stuff. The reason for that was to actually increase the flow, try and reduce the amount of time the water's on the ground. To do that, we had to modify some infrastructure, and we could have made all the demonstration sites fully automated. So whether the control was automated and the BIP sites. Therefore, the grower didn't have to worry about the sites, and all the data was collected. Demonstration site 3, 2022 trial plan on the left, very, very similar to the other trial plans. After seeing the results of these first year, the farmer turned around and said, I want to do my own trials within these trials. He was very, very curious about the outcomes and wanted to do his own modifications. So you can see C, F, I and L are 9-row strips. He did his own nutrient practices in those strips, and I'm not going to tell anyone what that is. I just think it's really important from a grower's perspective that he's asking the questions based off the data that he's been able to see. The demonstration sites also needed a good interface. It's no good collecting all this data and then having it just nowhere and not easy to use. So we've spent a lot of time to try and find the right interface to match this type of data. There's a lot of information coming in. A farmer also wants to know if there's a problem. So you get a notification. You can see the graphs on the other side here. If a battery voltage is going low or when an end of row sensor hits, farmer has all of this at his hands. It's easy. It can be anywhere in the world. It can be here right now and irrigating. Not an issue. You'll see the 2 blue zones. That tells the farmer that he's actually irrigating. Those two lines are irrigating right now. They're 60 rows each, so 120 rows are irrigating. They are the control on this particular demonstration site. The yellow is what he's got scheduled for the next 3 or 4 days. Here's the data from those 2 sets that you just saw. So you can imagine writing all this down on pieces of paper. Takes forever. This is just 2 sets. This farm has 20 sets, just this one block. The farm has about 130 sets all in total. So this is 2 sets. There's 24 irrigation events. Farmer didn't have to worry about it. Here's the BIP. We used Irrigation to schedule the irrigation events and change the way we irrigated by increasing the volumes. We were able to reduce it to 15 irrigations and capture rainfall events that normally would not be captured. Uploaded straight into Irrigation. So now the farmer has a graph that they can actually have a look at. The blue lines are the irrigations, the green is the rainfall events. Irrigation tells us that field 1 is wetter than field 2. But what we can also see on both sites is this sort of thing. What is that? That's a practical application. That's a spray job, a fertiliser application. You just can't irrigate every single time when you need to. There's different reasons why people do different things. What's important? It does a water balance. Irrigation does a water balance. You can see we reduced 5 megs a hectare, which collated to that much percentage in runoff losses, reduced. Deep drainage losses, reduced. Rainfall deep drainage losses, reduced. Combination was about 200 millimetres and deep drainage reduced. This is important, the yield. So now we've harvested the sectors. Like I said before, what's the point in going all this trouble if we have a yield impact? We had no yield impact. Some nervous times for us people doing these projects because you want to make sure you get good results. Very well done, big trials, results came back. Unsurprising to me, but interesting, 30% reduction in water use, equivalent to $134 a hectare in savings. The water monitoring component done by BIFMAC, Arwen's in the room here today. So we have low input sites, which is, and I'm sorry, that monitoring sites down the right is out of date. There's a lot more sites than that. But it just shows you the scope, the blue dots of where everything is and the red dots for the high input sites. The runoff volumes are really important. Her team take a reading at the top end of the farm. A flume is placed in the bottom end of the farm, so you know when the water hits and you know how long the water run off for. A lot of times as farmers, we don't get a chance to go back and capture it right when the water hits the end. The high input sites are a very similar setup, except for, you know, multiple flumes in each treatment, multiple sampling processes, multiple sensors, a lot more information. A hydrograph is produced from this data, and this actual hydrograph was very, very important. The growers, the farmers loved it. They said, this is great. We can actually see when the water's got switched off, how long it run for, and we can see the differences. And we can see there, we've got a 10-hour difference to a 2-hour difference. That's not unusual. That happens. Not every farmer can get to the farm when they need to get there. They're doing other things. So we had a 0.17 megalitre per hectare difference to 0.07 from our practice. So we're going the right way. That was site 13, or irrigation event 13. There's 14 irrigation events here. It's telling us the same story as what we just saw back in our water balance. We've got a number of between 15 and 32%. Our BIP practice back to 6 to 13%, and we know we can do better than that. It's all about calibration and trying to calibrate each individual farm. This one here, this is a really good example. 17.5 millimetre rain event, straight after you irrigated. That's what happens. That's excluded from that data, but that's really nice to show people just what actually happens if you get it wrong. And a lot of us get it wrong because we know the weather forecasting isn't good. We also had pesticide load runoff. Now, there's a lot of herbicides used on this because of wild sorghum, but you can actually see we've actually reduced the pesticide load by 50%. If we reduce the amount of water running off the paddock, it just makes sense. We reduce the amount of, it's a vector for taking nutrients, sediment and pesticides off the crop. All I'm showing here is that it's repeatable. You can see site 1 and site 2 very repeatable. And it's also practical. We had some dramas on site 2 that we've now been able to solve. We're going through to surge irrigation, which I haven't got time to explain. But using automation, you can do it. Communication engagement, 890 stakeholder engagement, key meetings, key stakeholders, 900 growers engaged across the process. In-kind support, really important. Lower Burdekin Water Board and Sunwater put a lot of money into this. I think those guys realise what we're trying to do is help improve productivity, profitability. TechLink gave us end-of-row sensors to trial. Outcomes. Grower interest in this automation technology was underestimated at the start of the project. The number of growers engaged in level 3 technology was 3 times the projected target. Similarly, growers were uninterested in partial automation. They wanted the whole thing. It makes sense. Growers' interest in the end of runoff monitoring was also as important, and it was given back to us, that information. Grower contribution of $650,000, that's in kind out of their own pockets. That shows you the interest they have in this. They're serious about this. They know that this sort of thing is going to help them in the future. 200 surface runoff observations, support adoption of on-farm innovation for the Lower Burdekin rising groundwater strategy. This has also been a part of this. Long-term demonstration sites that have measured outcomes for future investment and legacy. We need to keep these demonstration sites going. I have no money left anymore. Someone needs to help me. I'm trying to do this on a shoestring. Achieve the desired DIN outcomes for the project of 19 tonnes end of catchment. I don't believe that's a real number. It's a lot better than that. The farmers aren't getting acknowledgement for what they've done in this project. The tools that are used to assess this data does not capture that number correctly. 7,000 hectares of irrigation practice changed, 70 growers participated, average of 30% reduction in water use across demonstration sites, reduced deep drainage and runoff. Average is the same, 20 to 30% reduction in electrical energy use. One-on-one grower support, really important. Farmers have embraced the technology and value the automated record keeping. We've also got 2 other projects out of this where we've been able to put 2 more demonstration sites in, one in a legume crop and one over in another Delta site. Thank you. I'd like to thank all the investors and all the consortium partners and everyone who has been involved in the last 4 years. Thank you.